accurate restoration as compared with the rudimentary type of anatomy which we used to get from the machine restoration. And as Dr. Akshay sir told, the patient these days are not compromising with aesthetics. So with the use of a CAD-CAM technology, your aesthetics are not compromised and patient feels comfortable with the fit of a CAD-CAM generated restoration. Now this is another graph which is showing the percentage of restoration manufactured with CAD-CAM and versus the conventional method. Now as can be seen from the graph, the conventional method is lagging behind and the CAD-CAM has taken and it's occupying a significant portion in the graph, and over the coming years, in a decade from now, we would see most of the restorations done by a CAD-CAM only and the conventional method would be obsolete. What are the disadvantages of a CAD-CAM system? There are not much disadvantages, but the main disadvantages come that it requires a larger financial commitment. Also, for the safety net dental practices, these are not indicated because of the high cost. Also, the studies have shown that there is no good long-term clinical studies that are available for coping in framework with the help of by the use of a CAD-CAM. Now we come to chair-side versus lab CAD-CAM. There are two types of CAD-CAM that are available. One is a chair-side CAD-CAM and another is a chair-side lab CAD-CAM. The chair-side CAD-CAM is a single visit technique by which we use the intraoral scanner, which records all the minute details of the mouth, and the data is sent to the computer, where the CAD and CAM and milling is done, and you get the final product in the one day. Whereas the lab CAD-CAM can utilizes the help. We take the help of a manual. We take the help of a scanner by which we scan the model or the impression. So it has a two-way process. The chair-side CAD-CAM has an advantage that there is no impression making, and whether the hazards of making an impression by which we make an error or there is a gagging problem are eliminated with the use of a chair-side CAD-CAM. Also, laboratory casts are almost nothing because lab is not used. There is no temporary restoration required. We get eliminated as there is no modular die boring, and also it's highly accurate, and also the error, there is a less opportunity for an error for a chair-side CAD-CAM as compared to a traditional technique which we use. Disadvantages is only one, that high cost. Chair-side lab integrated technique is also quite accurate, but not as accurate as a chair-side single visit CAD-CAM technique. And the main disadvantages of this is it requires a two-visit. Otherwise, now I'll just name few CAD-CAM which are available in the market. First of that is Roland R machine. Then we have Geomagic, we have Dell-CAM, we have Renishaw, we have 3D System, 3M CAD-CAM, we have Cadent, we have CAD Blue, we have D4D Technologies. So these are all the various Dentsply, Circon, Serona. These are all the few names of the CAD-CAM which are available in the market. Now let me just show you the video which would give you an idea of a chair-side CAD-CAM, how the CAD-CAM and how the milling is done.
When your teeth need restoration, we can use CAD-CAM technology to create natural-looking inlays, on-raised crowns, or veneers in just one appointment. Our first step is to numb the area to make you comfortable. We may also use a rubber dam to protect your mouth while we work. Then, remove any decay and shape the tooth with a handpiece. Next, we apply a reflective powder to the prepared tooth. We then take a digital image using a special optical infrared camera that records the tooth's exact dimensions on the CAD-CAM computer. After we carefully design the restoration, we select an appropriate material of the proper shape for your specific tooth. We
place this material into the milling machine, which shapes it into a custom-fitted restoration. We then try in the new restoration, add any custom coloring as needed, bond or cement it in place, and polish it to a beautiful luster. Last, we'll check your bite and make any final adjustments. CAD-CAM restorations have several advantages. They are very accurate. Only a minimal amount of tooth preparation is needed, leaving more of the healthy tooth structure intact. They usually require only one appointment, even when we're working on more than one tooth. We can use the technology to custom make a wide variety of restorations, including inlays, onlays, crowns, and veneers. And CAD-CAM restorations are made out of tooth-colored materials. CAD-CAM restorations can often be the best choice for a healthy, beautiful smile.
So I conclude my basic lecture on digital dentistry. I hope it must have gave you an idea about the various terminologies and the various startups of how a CAD-CAM digital dentistry works. And I would like to say that what we encountered in clinics, if you see the picture from the right hand side, is we don't want a crude and a very old-fashioned clinic. What we demand these days is the left hand side clinic, which is much more accurate, advanced, and equipped with all the materials, where everything is available chair side, and which would save us time and give us more business. So this was all about the lecture. Thank you so much. And after that, the clinical lecture would be followed by Dr. Akshay Bhargav. And I hope you have must have got it. Thank you.
And I hope you do go back with some new information related to CAD-CAM, digital dentistry, and zirconia. Today, zirconia cannot be segregated from digital dentistry. I'll continue a little bit with what Dr. Paramjeet spoke on zirconia. And basically the topic today that we'll be discussing is how exactly the evidence, the research, the in vitro studies, how the new materials, how our application, what exactly is really happening as far as digital dentistry and zirconia is concerned. We all have some amount of somewhere, some form of some confusion when we talk about all ceramics, zirconia or PF. Somewhere there are some gray border areas where we do not know where to use what are the limitations of what. So, to cut it short, we will demystify the confusions surrounding zirconia. I cannot remove PFM because that is what most of you and all of us use. It is, I don't know still whether it is butter, but bread for me. So considering the fact, so through a series of popular myths, and what is the evidence? Because when we call it a myth, to say it is a myth, we have to give some support that it is no longer true. If we take the definition of a myth, myth basically means that, something that is popularly believed but need not be true. So, zirconia being a new material for the last 5 years, 8 years, 10 years, it doesn't have much evidence. There is still a lot of research going on. Every day some new thing comes up. For example, in between just 5 years back, 8 years back, they said the bonding between zirconia and porcelain is not good. You should not use it because it gets delaminated. Now, is it really true? I'll cover that. But question here is, would you wait for a trend to become an evidence before you really apply it? I mean, would you like to use your cell phone after all the research for 25 years has come out and prove that it is no longer harmful? Would you then like to buy a cell phone and use it? No. We are driven by market, we are driven by trends. And we cannot wait for every trend or everything that comes in the market to have a decade or 2 decade or 3 decade evidence before we use it. Okay? So, this was a concept earlier with most of the clinicians and researchers that unless something has really been proved and evidence-based, we are not going to use it. But today we are questioning these things because we do need to move up with and applying technology. Just briefly, what is zirconia? Is it a metal? Is it a ceramic? Is it an all ceramic? And actually, it's all three. Because of its use as a ceramic and because of its color, it's become all ceramic. But if you look at it in the periodic table, it is right below titanium. It has been derived from the word zargon, that is golden in color. It's an Arabic word, gold in color like. That is how it appears in the natural. India is one of the major resource areas where there is abundance of zirconia. We have USSR, USA, Brazil, South Africa, and then Australia. India is one of them, which is, and it is a metal of future. It's got excellent conductivity, it's got excellent industrial usage, many parts. I mean, you probably can't do without zirconia in the industries today. So, in any form of industry, but that's not the objective of the discussion, so we move ahead. Like again, what Dr. Paramjit said, tetragonal partially separates with yttrium. This is what we use in dentistry. You take zirconia as itself, you cannot use it. Only when you stabilize it with yttrium can you use it. Now why do we want this word yttrium? Because zirconia is not like cobalt chromium. It is a polymorphic material and it shows in different temperatures, different phases. The phase that we want to use is going to be at room temperature, but the phase that we create and want it to be stabilized at that phase is the tetragonal. I'll repeat again. What I mean is, you want something, you want water to have the strength of ice. So that means you retain the atomic structure and configuration that exist in ice, but that ice should not melt at room temperature. You want me to repeat it again, please? See, when you have ice, when you cool water, it becomes ice. This ice sank the Titanic, right? Can water sink the Titanic if you hit it? No. So the strength of the water came because it got transformed into ice. Now here, we have a tetragonal stage which is achieved above 1170 degrees centigrade. So when you heat zirconia above 1170 degrees centigrade, it changes into a tetragonal phase. Till then, from room temperature, it remains in monoclinic. See, it is not very, what do I say, unuseful information, because This information, I'll tell you how it's going to affect you in the practice. This tetragonal phase, unfortunately, the minute you bring it back to monoclinic, is unstable because there is a change in the size of the atoms or the crystals. Just limited to that, there's a 4% increase. This volumetric expansion causes a crumbling of the whole structure in monoclinic phase. Now we don't want that structure to follow because monoclinic is what it is going to be in room temperature, but we want to maintain the tetragonal phase properties. So we stabilize it with yttrium. 3 to 4%, 3 to 5% yttrium, cerium, etc. This leads to a phase transformation process. It leads, so what happens is when there's a crack in the structure, the crystals, because of yttrium and because of the tetragonal phase, prevent the crack from propagating. It is like what happens in your car windshield. आपकी जो गाड़ी का शीशा है, you'll see that the crack will slowly go. It's a toughened glass, and if it crumples, it will be in very, very small pieces. Something like that transformation. So this is the phases. I'll just come back to it. This monoclinic phase is the weakest phase. The minute in your crown and bridge, you take an air rotor and you start grinding the tooth. I'm telling you the clinical application. The tetragonal phase, the minute you apply stress, changes into monoclinic. And monoclinic phase is weak, and that is where the fracture can take place. Why the stress occurs? If you see sparking coming out, that means you reach zirconia. Do not grind more than that. You have a zirconia coping, you have a layer of ceramic over it. You want to remove high points, remove it. One more point of clinical use. When you get this grinding that you do due to the high points will be there because no articulator can behave like the mouth. Whatever movements, classical movements that take place in the TMJ, you have to finally remove it. Those high points, if you are removing it and you cannot send it for reglaze, if you send it for reglaze, you get back the optimum properties. But if you do not send it for reglaze, then I would advise that kindly please keep a polishing burr, silicone burr, polish that area. Then you will get back, as per the literature says, and even the studies that we've done, 50% of the strength is got back. That's hell of a lot. So, but at the same time, if you've removed enamel, you remove dentine from the veneered surface, and the substructure of zirconia is there, which you will identify by sparking, please do not grind more. Fine? Because the minute you touch it, it's going to get into again a different phase transform. So phase transformation, though it takes place at this temperature, it also changes by stress at room temperature. That's what I'm trying to say. This is how the crack is propagated. You have an induced crack. This is how the crack will go. You will have the transforming particles over here. Because of the stress, these particles are getting transformed from tetragonal to monoclinic. But the tetragonal which are outside, they are going to get compressed and they are going to prevent the tip from proceeding further. This crack is proceeding because this is getting transformed into this. I know it sounds a bit confusing, but all I can say is that whenever stress is applied on zirconia, it starts changing into a different phase. That phase, if it is controlled, you will have no problem. So coming to a little bit more applications in dentistry apart from this crown bridge. You have zirconia in all these areas. Implants, composites, brackets, post and core, veneers, extracoronal attachments, full and partial crowns. These are your This is a hybrid sort of an attachment. We just fuse it. Of course, these are no longer used because they've shown that they fracture. Why do we need a zirconia abutment? You see, the question is, जब metal का abutment is available, when metal is available, okay, let me ask all of you, why do we need zirconia? See, so far all of us are practicing without zirconia, no, without CAD-CAM. Why do we need today suddenly in our practice?
Aesthetics.
Aesthetics.
Precision.
Precision. What? Oh, you mean to say so far you are practicing anesthetically?
No, the thing is with CAD-CAM we can get the mark.
CAD-CAM will not give aesthetics. CAD-CAM will. Let's talk about. No, we talk one thing. You said aesthetics first. We come to the
Precision.
Okay, fit definitely yes, but I'll come to that also that a CAD-CAM. If your preparation is not good, okay. But let's come to aesthetics because that is the primary reason. Because CAD-CAM say you can get a metal again also. So CAD-CAM is a separate thing, but the question here is metal. Why are we switching or thinking of switching? Paramjit showed a slide. Okay, USA mein there's a drastic change, you know, which I saw just now, and you know, they see the amount. It appears that majority people have started incorporating zirconia in their practice, or all ceramics or whatever. And the reason, like you said, is aesthetics. So my question is it true that with zirconia we get better aesthetics?
Strength and aesthetics.
Okay, strength. But first thing, do we agree whether we get better aesthetics or not? Okay, let me rephrase the question. Do you feel कि कोपिंग आपकी मेटल की हो या zirconia की हो, उससे aesthetics में फर्क पड़ता है? Should I answer?
The metal is opacity, black color.
It's a hue. Reflection is there. Hue is there.
Okay, that's a good answer. He is saying, see, he's hit it actually on the nail, but I'll just explain if I may, right? Metal ceramics are hue based. आपको PFM की कोपिंग के ऊपर एक ओपेकर लगाना है.